What's up, pre-calculus students? So I was looking through your practice assessment. I realized that I'd have to grade things for you to get feedback. So that might not work out if you're doing the assessment like tonight. So I'm just going to record a video of me going through all the problems. That way, you can grade yourself and make sure you get the right answers. Okay. So here we go. First question should be pretty simple. What is the point at -1, 0? I mean, x-axis, y-axis. I know this is a circle, and sometimes it's confusing. Like, why do we have a circle? And thinking about things on axes, but things are normal. Hold on, get my pens all working. There we go. So this is to the right on the x-axis. Remember, points go, x's then y's. The only thing is this is a circle, so the maximum kind of distance away we can be is 1 because of the unit circle. All of these lengths here are 1. So if all of these lengths here are 1, and this length is 1, knowing that I start at the origin and I'm going to the left 1, that's why my x distance is -1. My y distance is 0 here at f. So the answer is F, not H. All right, so hopefully that makes sense to us. XY axis. This would be -1, 0. This is 0, 1. This is 1, 0. This is 0, -1. And then the other points really come from our triangles that we plop down. If we know this angle measurement is pi/6, this is a third of my quadrant. So if this angle measurement is pi/6, that's a 30-degree reference angle. Well, a 30-degree angle, we know that the triangle has got a short side, would be the vertical side, a longer side, which would be the horizontal side. Well, that means my x distance is √3/2 to get to this point here. My y distance is 1/2. I can start filling in all these values if I wanted to. 45, 45, 90 triangles, we know the lengths of a 45, 45, 90 triangle for, say, pi/4 would be √2/2 and √2/2. Anyways, that's just getting out of the way. Let's just keep going. Next one, what are the coordinates of point E? All right, well, there you go. This is an example of being at a pi/6, another pi/6 with a reference angle of 30 degrees, okay? So if this is 30 degrees away, then this must be some sort of pi/6. Now, the way I figure out the radian measurement is I say, okay, well, this is pi here at f. This is halfway around the circle. If the entire circle is 2 pi, and go around the circle, we get to 2 pi. So here's 0 here, go around the circle, 2 pi, half of that is pi. You can write pi as 6 pi/6, 3 pi/3, however you want to, so that you can use this fact to help you figure out what this is. Well, since this is a 6, this is a 6, I'm going to use the 6 pi/6. 1 pi/6 less, well, adding angles would be going around in the clockwise direction. Subtracting angles would be going around in the clockwise direction. I said counterclockwise here, clockwise here. So this should be 5 pi/6. So if I ask you what's the angle measurement of E, it's 5 pi/6 in radians. It would be 30 degrees away from 180, 150 degrees. And since it's 30 degrees, we know we have a short 30, 60, 90 triangle. I talked about this just before. The vertical side is going to be my shorter side, and the horizontal side is going to be my adjacent side. It's going to be my longer side, the √3/2 that we have memorized, these lengths of these triangles, this 30, 60, 90. Well, since I'm going to the left on the x-axis, this coordinate, this x coordinate is going to be negative. I say the distance is negative. And then I'm going up, so this is 1/2. So left and up, here the coordinates negative √3/2, comma 1/2. So, boom. I mean, you could have just gone off of the fact that, oh, no, you couldn't. Never mind. So there you go. There's the answer for the second question. Let's move on. Question number 3. What is the sine of point C? Well, here's point C. We can tell it's at this third major angle, that's a pi over 3. Pi over 3 is a 60-degree reference angle. So since this is a 60-degree reference angle, the side lengths are root 3 over 2 and 1/2. If you want to label the point, that's fine. The x is 1/2. The y, the vertical, is root 3 over 2. Sine is the opposite over the hypotenuse. The opposite is always the vertical. It's always the y. The y, the vertical, the opposite is root 3 over 2. Okay? So the sine of pi over 3 is root 3 over 2. Let's do another one. Tangent of point G. All right, it looks like point G is down here. It's the middle one. So the middle main one is going to be a pi over 4. It's going to be 45 degrees away. Okay, so 45-degree reference angle. Make my face bigger. There you go. 45-degree reference angle. We know the 45, 45, 90 triangles. When the hypotenuse is 1, the side lengths are root 2 over 2. I said root 2 over 2, but I wrote root 3 over 2. I'm going to keep attention. I'm going to pay attention to the direction I'm traveling in here. Since I'm in the third quadrant, I'm going to the left and going down. Left on the x-axis, down on the y-axis. This point is a negative and a negative. So these distances I consider to be negative and negatives. Tangent is opposite over adjacent. Opposite the reference angle divided by the adjacent. So that'd be negative root 2 over 2 divided by negative root 2 over 2. Well, something divided by itself, it's just 1. Okay, if you want to kind of go through the process so you see, you can cancel the 2's, cancel the square roots, and then the negative divided by a negative is a positive. All these different ways to see that this is 1. Okay, so you don't have to worry about rationalizing or anything for the tangent of point G. It is just 1. Moving on. Number 5. What quadrant is point H in? You just have to remember first quadrant, second quadrant, third quadrant, fourth quadrant. That's how we go around our axes. So H is in quadrant 4. Okay, it's where we got positives for x's and negatives for y's. Next one, number 6. What's the cosine 11 pi over 6? This is when we start after doing problems and you have to actually do them. So 11 pi over 6. Here's how I do it. This is how I teach you. First thing I do is understand that it's a pi over 6. And with a pi over 6, we're talking about a 30-degree reference angle with the x-axis. So I'm going to go ahead and draw, a y-axis and an x-axis. If you want to draw a circle, go ahead. But we kind of understand that we're only going as far as 1 unit away. And we're talking about hypotenuses of triangles with 1s. So I'm not going to do it. Instead, I need to find the location of 12 pi over 6. Of 11 pi over 6, sorry. Well, if we understand that this is pi and that this is 6 pi over 6, we know that it's not going to be in the second or the third quadrant. Because if you're 30 degrees away from pi, that's got to be 5 pi over 6, 7 pi over 6. It's got to be a number close to 6 pi over 6. Whereas over here, where we go around the entire circle, yes, this is a starting angle of 0 over here, but you go all the way around the circle, that's an angle of 2 pi. You can write 2 pi as 12 pi over 6. And then remember, adding is counterclockwise, subtracting would be clockwise. That puts me here in the fourth quadrant. Okay? And since it's a pi over 6, it's a 30-degree reference angle. It's a short 30, 60, 90 triangle. So my vertical side is the short side. The 1/2 is less than root 3 over 2. Root 3 over 2 is my longer side. One thing I'm paying attention to is the fact that I'm going down on my y-axis, okay? If you looked at this point here, it'd be a positive root 3 over 2, positive x, but I'm going down, it'd be a negative 1/2. Cosine is the adjacent, the horizontal, the x, adjacent, horizontal, x, whichever way you do, adjacent, horizontal, the x coordinate of that point where your terminal side ends is all root 3 over 2. Okay, now to type that in, because I believe you're going to have to do this on your test, you go pop into this this chat, this guy, and multiple things to do. You can click on this square root. Make sure the 3 is inside the square root. I saw a lot of people do like square root and then they're outside of it and they type the 3. So just like the square root of 3. And then either divided by 2. That doesn't work actually. No, we got to get outside the square root. So press right. And then you can go divided by 2. I'll accept that. I could also do the square root of 3. And then again, I'm outside things. And then you can turn this into a fraction, pressing this fraction button. 2. Okay? All different ways to do that. Okay? Let's go to the next problem. Sine of 3 pi over 2. So now we're at an extreme. So the extremes, how do we deal with these extremes? Okay, first we got to know where 3 pi over 2 is. Again, like ways to figure that out. First, you can have it kind of memorized and understood. Or you know that 2 pi is equivalent to 360 degrees. Well, half of that is pi. Half of that is pi over 2. Well, pi over 2 must be 90 degrees. So if I add pi over 2 to pi, if I add 90 degrees to 180, I get to 270. If I add pi over 2 to pi, I get 3 pi over 2. So it's right here. It's down here. Okay, now sine. If we talk about, I'm going to draw my circle just for this one example. Ooh, it's like an oval, but it will have to do. No, it's not going to have to do. I can do better. Come on, circle. Boom. Okay. Now, sine, SOHCAHTOA, opposite. With the unit circle, opposite is always vertical. You know, if this was our angle, whatever this side length is opposite. No matter what quadrant you're in. If we're talking about a reference angle to the x-axis, opposite is always the vertical distance. Okay? Another thing you could think of is, okay, the vertical distance will always be the y-coordinate. Here, you know, this is probably like a pi over 3. Okay, this vertical distance is root 3 over 2. Well, root 3 over 2 is the y-coordinate here. Over here, this is probably a 5 pi over 6. So, you know, the sine of this is 1/2. Yeah, it's the y-coordinate at that point. Okay, so either vertical distance, opposites, y-coordinates. 3 pi over 2 down here. Okay. Well, this point here, what is that point? Well, 0, because I don't go to the left or right at all. There's no movement on the x-axis. And I go down 1. How do I know I go down 1? It's a unit circle. All points from the origin to here are all a distance of 1. Okay? So you can either think, oh, I went down 1. Since sine is my vertical distance, sine of 3 pi over 2 must be -1. You'd be correct. Or you could say, okay, sine is always the y-coordinate of the point. Okay? Where it's kind of tricky is if you say sine is opposite. Because it's like, where's my angle and what's opposite of it? So that's why I kind of tell you guys, like, you go from opposite to vertical distance to coordinate. You could do that. Or I usually just go opposite to vertical distance. I don't even worry about the coordinates. For this one, it's like, just skip the opposite part. Go straight to vertical distance or coordinate so that you know that the answer here is -1. You type in a minus sign 1, that's fine. You can do 1 and then do plus a negative. Oh, no, don't do that. Never mind. Usually that's like a calculator symbol to make it a negative. But -1 is totally fine. Okay, you submit that, you get full credit. Next question. Tangent of pi. All right. So tangent is opposite over adjacent. Right? Here's pi. And we know that to get here, you're going to go to the left 1. And the coordinate is -1, 0. Okay. All right. So tangent of an angle, opposite over adjacent. Well, again, instead of opposites and adjacents, let's go to the next step and say, oh, it's my vertical distance, always on a unit circle, is always opposite, over my horizontal distance. Or you can go to the next step and say my vertical distance is my y distance, or my y coordinate. The horizontal distance is the x distance, or the x coordinate. Well, tangent, y over x, that's sine over cosine. It's like there's different ways to write tangent, okay? Well, if you think about it that way, vertical over horizontal, y over x, my vertical is 0, my horizontal is -1. My vertical is 0, my horizontal, -1. 0 over -1, which is 0. You just type in 0 here, and you're good. You can show me that you have 0 over 1 or -1, and that equals 0. That's fine too. Okay. I will give you partial credit if we have questions like this on the test, and you show me work, but then you mess up when you simplify. Okay, so hopefully that makes sense, why the tangent of pi is 0. Opposite over adjacent, or vertical over horizontal, or y over x. Next one. Cosecant, 5 pi over 4. Cosecant's the reciprocal of sine. We just have to know that. So let's make sure we know where 5 pi over 4 is and know the sine of 5 pi over 4. My recommendation for cosecant is you can either do hypotenuse over opposite, which is the flipped opposite over hypotenuse, or you can just find the sine and then flip it. So like, yes, cosecant an angle is equal to 1 over sine of the angle. All right, so 5 pi over 4 right there. Why do I know 5 pi over 4 is right there? It's a great question. This is pi, which is 4 pi over 4. 5 pi over 4 is 1 pi over 4 away. Now, is it here or is it here, knowing that pi over 4 is 45 degrees? Well, you should know, and this should not be crazy for you, is that if you are going in this direction, starting at 0, this angle over here is 0, then you will add, which puts us here in the third quadrant. Okay? Since it's a pi over 4, it's a 45-degree reference angle. We're talking about side lengths of √2 over 2. That's negative and that's negative because I'm going to the left and going down. You can list off the point if you want to, but it's not required, and I haven't been doing it so far, so whatever. Okay? Now, the sine. Sine is the vertical. The sine is -√2 over 2. So I got cosecant of 5 pi over 4 must equal 1 over the sine of 5 pi over 4, which is 1 over -√2 over 2. Or you could just say, like, the sine of 5 pi over 4 equals -√2 over 2. That means the cosecant of 5 pi over 4 must be this value flipped. I just keep the negative in the top. Who cares where the negative goes as long as we only have one of them, not two of them. Okay, so like if you did the same thing here, you could say 1 times 2 over -√2. And yeah, you just get -2 over √2. But what I ask you to do is rationalize things. The reason why we rationalize it, it's a more standard form. Back in the day when they had to do numerical approximations, they knew that it was easier to divide by a number, a whole number, rather than a root. That's the tough thing to do. So √2 times √2 is √4. √4 is the same as 2, or you can say √2 times √2, like the roots cancel. I don't want to say that, so let's just say √2 times √2 is √4, which is 2. And then you get your answer -√2. Okay? So found the sign, we flipped it, we simplified. You can put -√2. Keep it inside there, you're good. Okay? Let's do the next one. Secant is 0. Well, secant's reciprocal of cosine. So find the cosine of 0 and then flip it. Okay, now this is important. A lot of students really mess up on their concept of 0 as an angle. Okay, they're like, oh, 0, here's 0. No, that's not 0. That's the origin. That's not the angle 0. The angle 0 is here. This is the angle 0. It is you standing here looking off into the horizon. That's a 0 angle. That's a an opening side. Your angle needs two sides. So here's one side. Here's my other side. There's the angle of 0. Okay, and then we're adding angles when this side starts going up. So that's the angle of 0. It's not the origin. Make sure we understand that. Now again, on a unit circle, there's some distance to get here. I have to go over to the right 1, but I'm not going up or down at all. It's my x coordinate's 1, my y coordinate's 0. Okay, I go to the right 1. I don't go up or down at all. Okay, that is why the cosine of 0, cosine, adjacent, same as the horizontal distance, x distance. That's why the cosine of 0 is 1. Now, what's a secant? Well, flip 1. How do you flip 1? I don't know. You can take any number, put it over 1. There's a fraction. Flip that fraction. It's still just 1. Secant of 0 is just 1. Okay? Next one. Cotangent. 5 pi over 6. All right. Well, let's find 5 pi over 6. We found it before. It is in the third quadrant with a 30-degree reference angle, creating our short 30, 60, 90 triangle. There's my third quadrant. Here's my 30-degree reference angle. It is 1 pi over 6 less than 6 pi over 6. Here's subtracting, going in a clockwise direction. So here's 5 pi over 6. This is going to be the longer side. This is going to be my shorter side of my short 30, 60, 90 triangle. Cotangent, with cotangent, I don't like to find tangent and then flip it. I'm going to just go straight to cotangent. If tangent is opposite over hypotenuse in the TOA, opposite over adjacent in the TOA, and cotangent is going to be adjacent over opposite. It's going to be the flip of tangent, okay? So I'm going to say the cotangent of 5 pi over 6 is the adjacent, which is your x distance, divided by your opposite, which is your y distance. Then I can simplify this. Root 3 over 2 times 2 over 1. The 2's cancel. I get negative root 3. Okay? Cool. Type that in, negative root 3. Beautiful. Next. Name one positive and one negative coterminal angle for point E. I'm going to give you 3 as options, okay? Because a lot of people think E is like one of the angles, and then you have to add 30, 60. But we're doing it in degrees, okay? So first of all, E, that's a 30 degrees away from F, okay? We could tell, like, if we're using just 30s, 45s, and 60s, boom. E is going to be 30 degrees away. So if this is 180 degrees, then this must be 150 degrees. You can go ahead and write that as one of your angles. I mean, they didn't say like coterminal to 150. They say coterminal to E. Well, like 150 is at E. So that's good. Now, what's a coterminal? Well, you can just go around your circle and find another angle. It'd be a different angle, but it ends up in the same place. Just like when you're spinning around on a skateboard, you may end up in the same place as you would doing a different trick, but you're way cooler if you could do more and more spins. To figure this out, you just add 360. So that'd be 510. There you go. There's one coterminal angle. That's fine. Now you can use either of these for the positive ones. Now the negative would be like, oh, start at this angle. Let's go around the other way. Okay, let's go fakie or whatever they call it when you reverse the other way. Backside versus front side. I know my stuff. Subtract 360. Okay, like if I subtract 360, So let's see. That will be, I'm going to go 360 minus 150, then make the answer negative. So that's 210. Negative 210, that would be your negative coterminal angle. Another way I could have done that is just to go starting at angle 0, go down to negative 180, and then 30 more degrees. So negative 180, negative 190, negative 200, negative 210. So there you go. Here are two options for positive coterminal angles, and here's one option for a negative coterminal angle. Come on. It doesn't want to like do the whole circle or erase thing, which it was doing. Let's keep going. Next one. Radians now. Point F. All right. Well, F is pi. All right. So there's one of your answers. Now you can go around the entire circle, 360 degrees. What's that adding? 2 pi. Well, pi plus 2 pi, 3 pi. You can go around the other way. Subtract 2 pi. Pi minus 2 pi is negative pi. Or you could say, okay, A minus pi. That's easy. All right, so these are two options for your positive coterminal angle. This is an option for your negative coterminal angle. Oh, come on. Next one. Reference angle for point E. Yeah, we've talked about this before. 30 degrees. 30 degrees, pi over 6 radians. We know those are equivalent to each other. Okay? The reference angle is your angle created with the x-axis. Okay? That's 30 degrees. We should be good with that. 5 pi over 3. What is its reference angle? Well, we talked about all things simplified to be a pi over 3. 5 pi over 3 as the divided by 3. So we know that's 60 degrees. So there's your answer right there. Let's go to the next one. All right, these are the tricky ones. All right, these are very tricky. We got to talk about these. Okay, we got to match. Okay. Cosine, sine. What is that equal to? Blah, blah, blah. This is when we're talking about cofunctions earlier, where if you look at your first quadrant, boom, boom, boom. And, this point here had the taller y coordinate, the shorter x coordinate. So like it's the taller 30, 60, 90 triangle. So this point here is a 45, 45, 90. So root 2 over root 2. The side lengths are root 2 over 2. It's 45, 45, 90. And then this one, the horizontal distance is longer. So this horizontal distance is root 3 over 2. The vertical distance is 1/2. Okay, so let me just show you an example here. Like the cosine of pi over 6, okay, or the cosine of 30 degrees. Cosine of 30 degrees, here's 30 degrees, adjacent, horizontal, x, root 3 over 2. Well, if you take 90 degrees and subtract 30 degrees, you get 60, right? If you take pi over 2 and subtract pi over 6, you end up with pi over 3. Well, we will find that the sine of 90 minus that angle, or pi minus this angle, would also give us root 3 over 2, because like the sine is the vertical, and since these things just flip-flop, it works out. Okay? So take that, this will work, right? We know that it's not going to be equal to tangent, secant. Secant's the reciprocal. It's flipped. But this is the whole idea of the cofunction. Sine will be the same thing. If I take a sine value, the sine of pi over 3 is root 3 over 2. Well, the sine of the cosine of 90 minus 30 degrees here would be 60 degrees. The cosine is also 1/2. Sorry, I said the sine of pi over 6 is 1/2. Sorry, the sine of pi over 6 is 1/2. Well, the cosine of pi over 3 is 1/2. It works that self out because it's still a 30, 60, 90 triangle. So these are our first two. It's the whole idea of a cofunction. Well, the cofunctions are going to be the same for secant and secant being the reciprocal of cosine, cosecant reciprocal of sine. So that same thing is going to work out with the whole idea of the cofunction. Cotangent would be the same thing as tangent. No, hold on a second. Yes, because tangent is opposite over adjacent, cotangent is adjacent over opposite. It's really the same idea. They end up being cofunctions with each other. Okay. Same thing here. And now tangent and negative cotangent of pi minus 90. The best thing to do is just to do a couple like examples. Let's take pi over 3, okay, which is 60 degrees. Okay, so 60 degrees minus 90 is negative 30. Let's find the tangent of 60 degrees. Root 3 over 2 divided by 1/2 is root 3. Okay, so tangent of 60 degrees. Now, what if I do negative cotangent 60 minus 90? Negative cotangent of negative 30. Okay, well, negative 30 degrees is here, and that's going to be vertical of 1/2, a horizontal of vertical of negative 1/2, a horizontal of root 3 over 2. Okay, cotangent is adjacent over opposite. Okay, so adjacent is the root 3 over 2 over the opposite. Okay, that's 1/2. So that ends up with a negative root 3. We take the negative of that, it becomes positive root 3. That's why these guys are cofunctions with each other. These guys work out. Okay, how did I figure this stuff out? Examples or help for situations like this is to just plug in some angles and see which ones does it work. You know, I could have plugged in pi over 3 here. Usually pi over 3 or pi over 6 is good. Cosine of pi over 3 is 1/2. Pi over 2 minus pi over 3 ends up being pi over 6. The sine of pi over 6 is 1/2. So this is a tricky one, probably the trickiest one that you had is this matching of cofunctions. These are easy. We've done these so much. There's nothing fancy. I told you, like, you just got to know this. Okay, the proofs behind the side lengths are out there. You can use the Pythagorean theorem. For a 30, 60, 90, you kind of have to expand the triangle and use the equilateral and like a perpendicular bisector. But anyways, side lengths of a 30, 60, 90, there's a longer, there's a shorter. This is what we use all the time. So this should not be crazy, okay? Side lengths for a 45, 45, 90, we use all the time in our unit circle. It's root 2 over 2, root 2 over 2. Not crazy here. Root 2 over 2 for both. Okay, 19. All students take calculus. Don't worry about it. Honestly, just don't worry about it. It's what I use when we start doing things like solving trig equations. What you do is you do A in the first quadrant, S in the second quadrant, T in the third quadrant, and C in the fourth quadrant. And what this is just like a special simple mnemonic that helps you know which trig functions and their reciprocals are positive in which quadrants. So like this stands for all trig functions are positive in the first quadrant. Sine, cosine, tangent, cosecant, secant, cotangent. This is sine and its reciprocal cosecant. Only sine and cosecant are positive in the second quadrant. Cosine is going to be negative. Tangent's going to be negative because it's like the sine over the cosine, the y over the x. And the x is always negative. So just that. The third quadrant, we have negative x's and negative y's. Only tangent's positive because we have y's over x's, negatives divided by negatives. Well, only tangent will make that negative divided by negative occur. Everything else is going to be like a negative divided by the hypotenuse of 1. So we don't do that. And then here in the fourth quadrant, cosine and its reciprocal secant are positive. So this is just a mnemonic that might help you. It might not. Like you can kind of instead of worrying about lefts, rights, ups, and downs, you can kind of be like, where is the location? And then use this. But I probably wouldn't recommend it. And we'll use it when we start solving trig equations more. So don't worry about this question. Convert 2 pi over 3 into degrees. I mean, like, you don't have to use the conversion for this one. It's like 2 pi over 3 is here. It's a reference angle of 60 degrees. Don't tell me that it's 60 degrees, though. That's the reference angle. The reference angle would be this angle. The actual angle is like that obtuse angle that you create. So it's got to be 90 plus 30, which is 120. Okay, boom. That's one way you could do it. 60 away from 180 or 90 plus 30, one way to do it. The other way to do it is to use the conversion, where if you want radians and you want to turn things into degrees, you can use the conversion, the equality, that there are 2 pi radians and 360 degrees. Again, these are in rads. So since this is radians, I want to get rid of the radians. So I need radians in my denominator. 360 degrees, equivalent to 2 pi radians. Boom. Cancel, cancel. 360 divided by 3. You can either use a calculator or you can figure out that it's 120. Oh, just messed up. Okay, so good. Next one. Last one. I'll post this video. 440. Convert it to radians. This one's not an easy one. Okay, I can think about it like in differences from 360. So it's 80 degrees away. Well, 80 degrees is not like a radian measurement that we know. We can work our way there, but no, it's not. We like to deal with the 30s and the 60s and the 45s. So I got to convert this. So we got 440 degrees. I want to convert into radians. So I'm going to need to cancel my degrees here. 360 is going to go down there. And I'm going to leave radians. 2 pi radians is equivalent to 360 degrees. My degrees cancel. Now I got to do a little bit of work. Probably best to not use 2 pi over 360. Probably best to use pi over 180. And literally, if you just write this as your answer, I'll accept it. But we can simplify this even more, right? How can you simplify it? Divide by 10, the top and bottom by 10. Okay. 44 pi over 18. Simplify that. Divide everything by 2. Top becomes 22 pi, the bottom becomes 9. Let's see, I can divide 9 by 3, but I can't divide 22 by 3. I'm done. If you have one of those fancy calculators that simplifies fractions, leave the pi out, do 440 times 2 divided by 360, and then boom, simplify. Now, what I saw on some of your answers already was people saying this is 2.4 pi. No, wrong. 2.4 is not 22 divided by 9. You might be like, yes, it is. Look, it's 2.4. No. That's 2.4 repeated. That is different. In this class, we need to start getting used to, like, we don't want to round. Okay, we want exact answers. Okay, now that means unless your decimal stops, we're never going to use decimals as answers. Okay, this decimal does not stop, so I want the exact answer, which is 22 divided by 9. 22 ninths is the exact answer. Okay, you're not going to write 2.4. I will not give you credit. If you say 2, that's definitely not right. Okay, 2 pi is 360, not 440. Okay, so lesson for you guys: don't write down decimals unless you see the decimal stopping. Like 2.125. Yeah, I'll accept that. 2.125 pi. But if it's 2.125 and then on your calculator it's like 69342 and it keeps going, I will not accept 2.125. Okay, so that's it. 22 ninths pi. That's the video here. That's our lesson. I hope you guys watch this, understand all the questions, do the extra practice problems, watch my video. Practice makes perfect. And you have to master this stuff moving forward in this class because it doesn't go away. All right, later.